Howdy, everyone. Welcome to our presentation on cloud and networking. I'm Adrian,
I'm Alvin.
And I'm Aiden.
and today we'll be walking through how to set up a secure WordPress website in the cloud and using Wireshark to analyze network traffic. Our goal is to show you how modern web services can deploy securely and how you can see what really happens under the hood. So just a brief overview of what we'll be discussing today is enabling HTTPS on WordPress, an overview on how to activate HTTPS on a WordPress site, including the process of obtaining and installing SSL certificates to secure website traffic.
We will then go over configuring SSL key on Wireshark through step-by-step instructions for setting up SSL keys in Wireshark to enable the decryption and analysis of encrypted HTTPS traffic.
Lastly, we'll look at the HTTPS analysis, which is techniques for capturing, decrypting, and interpreting HTTPS network data using Wireshark and gaining insights into secure communications.
So first, we'll be getting into enabling HTTPS on WordPress. Now, if you look at how we set up both WordPress and Wireshark for our project, the WordPress setup, we started by launching a new EC2 instance on AWS to host our website. We used a custom script to automate the WordPress installation, making the process quick and repeatable. After installation, we verified everything was working by accessing the WordPress site through our public IP4 address on our EC2 instance. On the Wireshark side, our setup was simple. We downloaded and installed Wireshark directly from the official website. This tool let us capture and analyze the network traffic to and from our WordPress server. With both environments ready, we were set up to explore secure communications and analyze HTTPS traffic. Enabling HTTPS. First, under the Obtain and Install SSL certificate, you see the steps to getting an SSL certificate either from the Trusted Certificate Authority or a free provider like Let's Encrypt. We generate a certificate and a private key, then installed it on our web server. On the right, under Configure WordPress for HTTPS, we highlight the use of NoIP. NoIP gives us a dynamic domain name that always points to our current server IP, even if it changes. After getting the set up on the SSL certificate for our NoIP domain, we updated our WordPress setting to use HTTPS so all site traffic is secure. These two steps together ensure our website is protected and always accessible at a secure, easy to remember URL.
Next, we will go on to about configuring SSL keys on Wireshark. In the next slide, to start, let's talk about setting up SSL key logging. As shown in the screenshot, you need to open your system properties and add a new environment variable called SSL key log file. Set it to a path like in your C drive SSL keys, SSL key log.log. This makes browsers like Chrome or Firefox save all the session keys they use for HTTPS connections into this file. Those session keys will let us decrypt encrypted traffic later in Wireshark. You can see in the screenshot the new variable being added and what the log file looks like, just lines of secret keys. In the next slide, once the SSL keylog file is generated, the next step is to set it up in Wireshark. In the screenshot, you can see we've entered the log file location under Wireshark's TLS protocol settings right here, where it says pre-master secret log file name. By doing this, Wireshark can use the session keys from our browser to automatically decrypt and display HTTPS TLS traffic, making it easy to analyze all the encrypted communications between our WordPress site and its visitors.
Lastly, let's take a look at HTTPS analysis. Uh, bef- Before anything else, let's look at what happens in Wireshark before we use the SSL keys. In the top right screenshot, you can see data, or you can see details from the TLS handshake. The SNI or server name indication tells us what website is being contacted. In this case, ajschreierprojects.zapto.org. But as the packet capture shows, all the application data is still encrypted. Wireshark can show us the handshake and some metadata, but we can't see all the web content or user activity yet. Now, now that the SSL key has now that the SSL keylog has been loaded into Wireshark, HTTPS traffic and reveal the full contents of the communication between client and server. It's the handshake metadata. In this example, we see readable application data like HTTP GET request at the bottom. This level of visibility is crucial for analyzing encrypted traffic during debugging or security research. Finally, in the section, we have decoded HTTP GET. Finally, in the HTTPS traffic section, we have decoded the HTTP GET request and response, showing the kind of web data that you can analyze once you have the SSL key logged and enabled. Let's walk through the HTTP or the TLS handshake shown in this capture. First, we have the client hello, which you can see in the top, or which you can see in the bottom left corner. This client initiates the connection and by sending its supported TLS version, client or cipher suite, and server name, and the server name at once to connect to. In this case, our web server. Then in the top left corner, we see the server hello. This server responds by selecting security settings, sending the pre-shared key, and signaling that it's ready to begin encrypted communication. It also sends a change cipher spec message and the first encrypted application data. This exchange forms the foundation of our secure HTTPS session. Now, some of the highlights of the information that we get from after SSL. We've decrypted the HTTP traffic, which means we can see previously encrypted HTTPS packets as clear HTTP requests and responses. This means that we can actually see the data exchanged between the client and server instead of just non-encrypted nonsense. We have full visibility into our communication, including detailed protocol metadata and the exact contents of our web sessions, so we can actually analyze them. This lets us troubleshoot, secure, and monitor user actions in clear text. Lastly, we can see the server key exchange. This occurs during the TLS handshake when needed, and the server sends a key exchange or its key exchange parameters and allows the client to compute a shared secret. This ensures forward secrecy, meaning that past sessions stay secure even if long-term keys are compromised.
And we want to thank you for just taking the time to listen to our presentation, and hopefully we're able to capture all about cloud and networking.